So we'll do matrix multiplication today. And this is where it can get a little bit confusing, not confusing, people forget a bit. So matrix multiplication. There are some rules. You just can't multiply any matrix with any other matrix, okay? A matrix A can be multiplied with a matrix B if and only if the columns of A equate with the rows of B. Have you understood? Two matrices can be multiplied only if the columns of A, columns means with the one with whom you are starting, the columns of A should match with the rows. So you should always remember one diagram when you make matrix multiplication. This diagram, always remember this. This is how the job goes. Don't draw it the other way around. Draw it the way I drew. This. Columns with the rows. Okay. So say suppose my A was a M cross N matrix. Then my B has to be a N cross something. It can be a N cross P. Agreed? They will give birth to a matrix which will be C, and both the N's inner ones will cancel, the outer ones will prevail, so it will be a M cross P matrix. Please get this thing as much time as you take. It is very easy but very difficult, very easy to forget. A matrix can be multiplied with another matrix only if the preceding matrix count of columns equate to that of the other matrix or the succeeding matrix count of rows. That's why the diagram is always this, column followed by rows. Another way people remember is CA. CA of the chartered accountant should be equal to red blood of the other. CA should be equal to RB. That's how you remember. Okay? Which makes us have one conclusion, children. Square matrices can always be multiplied with each other, because in square matrix is a special matrix where the number of rows and columns always equate to each other. So if this is a square matrix of an order of the same order, two square matrix of the same order. Now if this is a square matrix of order 3 and this is a square matrix of order 2, then there will be a problem. Two square matrix of the same order can always be multiplied, right? So let's do one matrix multiplication first, and then we will see other properties. I'm taking book example because it helps us to get the data correct. So I have a matrix C, and C is given by 1, minus 1, 2, and given by 0, 3, 4. So this is a matrix, and I have a matrix D, which is 2, 7, minus 1, 1, and 5, negative 4. This is another matrix. And I'm asked, is the multiplication CD possible? If so, do CD. So let's first say CD. CD in terms of rows into column, how many rows, beta? 2 rows, 3 columns. And if you look at this, this is 3 rows, 2 columns. Always look at the inners. The inners are matching. Ananya, able to follow, beta? The inners are matching. That means the matrix CD that I get, children, it has to be a square matrix which will be a 2 cross 2. Now, how do we get CD? How do we get CD? We follow the diagram that I have shown you, this diagram, right? So, how will you start multiplying this matrix? You can take its column and multiply each of. See, if you take 1 column, 2 column, 3 column, you should get 3 rows. 1 row, 2 row, 3 rows. Right? And if you would have taken its rows, yeah, this, 3. It will tell you. Or else if you take these 2, then it's these 2. Okay? So how do we start? We'll first multiply 1 into 2, then How are you going? You're going in which order? You tell me.
The first column of D.
For multiplying the first column of D with the first row of C. No issues. So let's do that. So to do that, if you're multiplying the first column of D with the first row of C, then I take 1 multiplied by 2. Agreed? 1 is being multiplied by 2 added with -1 multiplied with -1 added with 2 multiplied with 5. That is my first element. Agreed, children? I have to get a 2 cross 2. So the next one would be, I take this and I kill this row. So it will be a 1 multiplied by 7 plus a -1 with a 1 and a 2 with a -4. So look, my first row has played with both the columns. Job done. Now my second row starts playing with column. I have to get a 2 by 2 matrix. So 0 multiplied by 2 plus 3 multiplied by -1, 4 multiplied by 5. Similarly, 0 multiplied by 7, then 3 multiplied by 1 plus 4 multiplied by -4. Look, isn't it a 2 by 2 matrix? It's a 2 by 2 matrix. Try to do it and report the answer. Multiplication order is, in fact, the way you want to remember multiplication order, you have followed this order. You have followed this order. What is the matrix you got, beta? 13 minus 2, 17 minus 13. All of you got that? I'll wait for you. Ananya, I'll wait for you. Don't worry. Finish it. This is clumsy, but we have to do. So series value is 1 into 2 is 2. 2 plus 1 into 1, 1. 2 plus 1, 3 plus 10, 13. Then 7 minus 1, which is 6. 6 minus 8. 6 minus 8 is minus 2. 2, this is 0. Minus 3 and 20. Minus 3 and 20 makes it 17. And 3 and minus 16 will make it how much? Minus 13. Right? Shall we do one more now? Chalo, let's do one more. A is a matrix. You need to find AB, children. Find out the value of AB. Given that the matrix A is a 2 by 2 matrix, 6, 9, 2, 3. And we have matrix B, which is given by 2, 6, 0, 7, 9, 8. So ask yourself, rows into column, this is a 2 cross 2. Rows into column, this is 2 cross 3. Inners are matching. That means this matrix multiplication is possible. And AB will be a matrix which will be a 2 cross 3. Now you try to do it on your own. Horizontal followed by the vertical. Horizontal with vertical. Is we clear? Okay. Ananya, is comfortable? Okay, do this one. ठीक तो सार्थक समझ में आया तो हाँ Shall we? So we'll have 6 multiplied by 2 plus a 9 multiplied by 7. Very good. 2 cross 3 means 2 rows, 3 columns. Then we should have 6 multiplied by 6 plus 9 multiplied by 9. Then we should have 6 cross 0 plus 9 cross 8. Okay, next series. Then this will be 2 cross 3. 2 rows, 3 columns. Okay, this is done. Then we say 2, 3. 2 cross 2 plus 3 cross 7. After that, 2 cross 6 plus 3 cross 9. After that, 2 cross 0 plus 3 cross 8. So let's find AB finally. So this is 6 to 12. 7 plus 9 is 63. 73, 74. Sorry, 75. 75. Then this is 66, 36, 99, 81. 81, 91, 101, 111, 117. Then this is 0, 8, 9, 72. 4 and 21 makes it 25. 12 and 9 3s are 27. 37, 39. And this is 3 8s are 24. Is this the answer? Okay. This is very easy to learn, easy to forget chapter. Okay. Take an attempt of doing B cross A. B cross A. B cross A. Just try to do B cross A. B is 2 cross 3. A is 2 cross 2. The inners don't match. Therefore, B cross A is not valid. You cannot do. Which brings us to one conclusion, that the commutative property for multiplication, not addition. In addition, commutative was satisfied. Commutative property for multiplication does not hold always. Means, now you could have asked me, sir, why did you not say that commutative property does not hold? I'm saying does not hold always. Means there will be some place where it will hold. So I'm trying to say something, children. And AB may not be equal to BA. First of all, where an AB and BA may not be possible itself. However, if you have diagonal matrices, Achha, what is the difference between a scalar matrix? A scalar matrix is a matrix. Tell me the difference between, tell me square, scalar, diagonal, identity. Let's see. Square matrix, number of rows equal to number of columns. What is a scalar matrix? Once again, before we go to the next problem. Square matrix. Once for all. Square matrix is a matrix which is a M cross M. Means the same number of rows and the same number of columns. Got it? Okay. After square comes diagonal. After square comes diagonal. Diagonal matrix is a matrix which is a square matrix, but it will be something like, say, 3 0 0 0 5 0 0 0 9. This is diagonal matrix. Understood? Diagonal becomes scalar if the diagonal elements are same. 3 0 0 0 3 0 0 0 3. Scalar becomes identity when the diagonal is 1. This one, just make a note of it. Square, diagonal, scalar, identity. Square, diagonal, scalar, identity. Okay? Square, diagonal, scalar, identity. Okay, going back. Now I said this is not always A into B, may not be B into A. Maybe B into A is not feasible also. However, if you have diagonal matrix, let's take a diagonal matrix. Diagonal matrix means take a 2 by 2. That's the simplest. So how do you make a diagonal matrix? 3, or make a more smaller number. Say 2, 0, 0, 1. Is this a diagonal matrix? This is a diagonal matrix. Okay. And try to multiply this matrix with, say, 3, 0 and 0 minus 1. Right? This is your A and this is your B. Now you will be able to see that AB is equal to BA. Just do and see. This is again an assertion reasoning question. Matrix multiplication is commutative only if the matrix involved are diagonal matrix. That means this will hold for diagonal, scalar, identity. Try and do this AB and BA and you will see AB and BA. First of all, Sarthak, if it is a square matrix, we need not even check row column criteria.
Yeah.
Square matrix multiplication is always possible. We need not even check. How much did you get when you tried to do AB? 2 into 3 is 6 and 0 into 0 is 0. So it will give you a 6. 2 into 0, 0, 0 into 1, 0, 0. And then 0 into 3 is 0 plus 1 into 0 is 0, 0. And on the other side, what do you get? 0 into 0 is 0 and 1 into plus 1 into minus 1 is minus 1. 6, 0, 0, minus 1. Did you get that? Yeah. Now can you do swap it and do? Means do BA, which is 3, 0, 0, minus 1 multiplied with 2, 0, 0, 1. 3 into 2 is 6 and rest is 0. Then 0 into 1, 0 into 0 is 0. 0 plus 3 into 0, 0. Then 3 into 0 is 0. 0 into 1 is 0. Then 0 into 2 is 0. 0 into 0 is 0. Minus 1 into 1 is 0. Minus 1 into 1 minus 1. See, here it is satisfied. AB is equal to BA. So write a nice note. Matrix multiplication is not commutative. Sometimes A cross B, B cross A need not be feasible at all. However, if A cross B is equal to B cross A, it is understood that the participating matrices are diagonal matrix. Because now mathematics in your CBSE has a lot of assertion reasoning questions also, and there are questions based on true or false, fill in the blanks, where you actually need to have your theory content proper. You wrote that note? Matrix multiplication is not commutative. If the matrix multiplication is commutative, it means that the participating matrices are diagonal matrices. Yes, children? Understood? Okay. Matrix multiplication will follow associative law.
Any square matrix, AB should be equal to B.
Any square matrix, only for diagonal it will be.
No, but like the inners of both the matrices will be the same.
No, but the product may not be same. Na? Row into column, there you are making the row different and the column different. Multiplication is possible. You should frame your question like this. For any two square matrix, do not need to check the order. Multiplication is guaranteed. You want to check it? We'll check it. Come. Let's take one square matrix. 1, 2, and let's say 2, 3. Take this one and multiply this with minus 1, 2, and say minus 3, 1. Right? Do this multiplication first. AB. This multiplication is very much possible, children, because it's a square matrix. Shall we? Let's do this. AB. 1 into minus 1 is minus 1. Plus 2 into minus 3 is minus 6. So this will be minus 7. Then 1 into 2 is 2 and 2 into 1 is 2. So this will be 4. Then 2 into minus 1 is minus 2. 3 into minus 3 is minus 9. So this is minus 11. 2 into 2, 4 and 3 into 1, 4. 3 into 1, 3. So this should be 7. Just check. Yes, got it. I may also be wrong, huh? I am now, my processor is very old. Now let's do BA. Minus 1 into minus 1 is minus 1. 2 into 2 is 4. So you straight away get 3. Next Sarthak. Yahi fail ho gaya. Minus 1 into 1 is minus 1. 2 into 2 is 4. So this gives you 3. Anyway, we'll populate it. Then minus 1 into 2 is minus 2. 2 3s are 6. So this is 4. Then minus 3 into 1 is minus 3. 1 into 1 is 2, which is gives you minus 1. Minus 3, 2 is minus 6. And 1 into 3, 3. This is minus 3. Where is it equal? It will work. That's what I said. It will give you a diagonal only. That means if you see that, yeah, Zoe, tell me. If it is diagonal into diagonal. What is buzzing? Somebody's mobile or something? Ah. Okay. Is this fine? Understood? So we will see what are the properties of matrix multiplication. Matrix multiplication. Now tell me, children, commutative property. Are we clear on this or not? Commutative property. Commutative property says AB need not be equal to BA. If AB is equal to BA, then A and B are diagonal matrix. Where the diagonal elements need not be same. They need not be scalar or identity. But in scalar identity also they will support. Diagonal is the most lenient diagonal matrix. More stricter is scalar, more stricter is identity. Okay? Okay. It also follows associative. Associative, what does it tell us, children? The order in which you are multiplying. Means if you multiply AB first and then do C, it is same as you multiply BC first and then you multiply BC, the product with A. This is associative. Clear? And matrix multiplication will always do distributive property also. Suppose you have a A plus B and you're trying to multiply it with C. That's same as an AC being multiplied and added over the product BC. This is known as distributive. So this property is also supported. Now, grade 8. You remember there was something called multiplicative identity of rational numbers. Let's go to grade 8. A rational number P by Q, when multiplied by something, what are we trying to multiply with? Identity. Remember the word identity card. Is your photograph and your photograph in identity card the same? That way. Yeah, it has to be same. It's you only. So you should get here the same PQ. So what is a multiplicative identity? 1 in rational numbers. And multiplicative inverse used to be the reciprocal of the number with which you multiply and you used to get 1. Right? So now we are going to search for multiplicative identity for a matrix. Means a matrix multiplied by such a matrix that you should get the matrix returned back. Matrix multiplied by another matrix so that you should get the matrix back. Shall we? So we say multiplicative identity. Multiplicative identity. And this will be what you will be using a lot in determinants to actually find inverse of a matrix also. Multiplicative identity. So we write for every square matrix A, there is an identity matrix I of same order such that if you do AI, you should get back A. For every square matrix, there exists an identity matrix of some same order such that if you do AI, you should get A. And when you do AI, children, once again, square matrix multiplied by an identity matrix. Identity matrix is so stylish that IA and AI will be same. You need not worry about that. Yeah, it's identity. Diagonal, okay, come here. Two diagonals is commutative, a square and an identity. An identity is 0, 1, 1. It will not change the value. You will get the same thing. Let's try and do. Do this. 2, 1, right? And say minus 1, minus 2. Try to multiply this, children, by a 1, 0, 0, 1. Just check. 2 into 1 is 2 plus 1 into 0 is 0. So we will get a 2 out here. 2 into 0 is 0 plus 1 into 1 is 1. So get a 1 here. Minus 1 into 1 is minus 1 and minus 2 into 0. Then minus 1 into 0 is 0, minus 2 into 1 is minus 2. Didn't we get the same thing? Okay, can you do this multiplication? 1, 0, 0, 1 and you try to multiply it by 2, 1, minus 1, minus 2. Let's check this. 1 into 2 gives me a 2 and then you have a 0. So it's a 2. You get a 1. Then you get a minus 1 here. And if you do this, this is a minus 2. Yes, same. Multiplicative identity. This will be used a lot. A multiplicative identity is a, if you have a square matrix, always remember the criteria. If I have a square matrix, then there is another identity matrix of the same order as my parent square matrix. Multiplication of whom with the matrix will yield the matrix itself. So for A, there exists an identity matrix I of the same order such that AI is equal to A or IA is also equal to A. If that be the case, these are all, you can do these examples at home. If we do one example, the whole class will not finish. Okay, one question. This you all do. 1, 2, 3, minus 3, 2, 1. 1, 2, 3, minus 3, 2, 1. 3 minus 2, 1, sorry. 3 minus 2, 4. 3 minus 2, 1. And followed by our next data is 4 to 1. Okay, don't curse me, huh? If this is the matrix, then show. Wait. 40i. 23a is a scalar multiple. Doesn't make that big difference. The problem will be in a cube. Yeah. Tell me. Oh, I have got. Okay, tell me how many chemistry books, how many physics, and how many economics books. I've got 120, 96, 120. And what are the prices? 80 rupees each, then, and 40 rupees each. I want to find out by selling everything how much money I'll get using matrix algebra. So if the books are represented by a matrix B, and B I write as 120, 96, 120, that means this is how many rows and how many columns? 1 row, 3 columns. Basically, we have to multiply and add both, right? So my price matrix has to be how much? My price matrix has to be, the inner should be 3 rows and 1 column. Ultimately, you'll get one figure, right? What is that one figure? The net revenue that you'll generate. So your final matrix has to be a 1 cross 1. So this will be the prices 80, 60, 40. Did you understand, children? 3 and 3 match means this matrix multiplication is possible, and my revenue will be given by books multiplied by the price, which will be a matrix which will be 1 cross 1. Can you get me the value now? Twelve eights are 96, 0, 0. With this we will add. How much will we add? 96 into 60. 6, 6, 36, 6, 3 carry over. 6, 9, 54 plus 3, 57. With this we will add 120 into 4. 12 4s are 48. This is your final matrix. How much is it? 0, 6. 14 plus 7, 21, 2. 2 plus 4, 6. 6 plus 5, 11. 11 plus 9, 20. Huh? 0, 6. 8 plus 6 is 14. 14 plus 7, 21. 1, 2 carry over. 2 and 4, 6. 6 and 5, 11 plus 9, 20. 20,160 rupees you will be getting. Clear? We'll just do one topic and then we'll close for today. In the next class, we will get into skew and symmetric matrix. Okay. So this actually brings you for your next exercise, which is a very laborious exercise of 3.2. Nothing is tough. Everything is only calculations. Nothing is tough. Shall we? Our last topic of the day. Transpose. Transpose of a matrix A is denoted by AT, or people write it as A complement. A complement. How do we write it as? AT or A complement. And this matrix is formed by interchanging elements of rows and columns. You interchange the elements of rows and columns. This means a very interesting thing will happen. If I have a matrix A and my A matrix is a M cross N matrix, then children, what do you think should be A transpose? Rows become column, columns become rows. So this will become N cross M. Right. So shall we take one? 3, 5, root 3, 1, 0, 3, 5, root 3, 1, 0 and minus half. This is a matrix, say C. Can you get me what is C prime? So tell me the order of this. 3 rows, 2 columns. Ananya, did you understand transpose of a matrix? A matrix transpose is very easy. You will just swap the rows as the column. Columns will become rows. Do you prepare your timetable? How do you prepare? You prepare periods and days. If you swap the timetable, then it becomes days and periods. So that is called a transpose timetable. So this will become what? Tell me now. 3 root 3, 0, 5, 1, negative half. So this has now turned out to be 2 rows, 3 columns. a very interesting thing. Is a multiplication now possible?
Yes.
Multiplication will yield you what? Look at here and say square matrix. Multiplication will yield you square matrix. Have you understood? Matrix. Yeah, so he is already drenched out. So if you have matrix and its transpose, their multiplication. Ananya, did you understand? Multiplication is possible. Now see, the inner values are same. And the new order of the product matrix will be a square matrix. Understood? Next class we will be doing where we do that if the matrix and its transpose are same, then it is called a symmetric matrix. And if the matrix and the transpose are not same means by a negative, then we call it as a skew symmetric matrix. So that is in next class. Before that, we have to have some properties. Matrix is like inverse. Achha, tell me one thing, one property, let us see. You have taken transpose of a matrix, means this one you have inverted. If you take transpose again, so clear? Okay, let's see some properties and then we close. Then suppose if you have A plus B as a transpose, it is same as A transpose added with B transpose. Nothing to remember. Apply common sense, it will work. Addition is possible only when the orders are same. Tell me, children, A plus B, if you transpose it, the orders remain the same. Okay. If you have a scalar multiple with a matrix and you take its transpose, it is same as transposing the matrix and then multiplying the scalar. And finally, if you have product of two matrices and you have taken their transpose, it is same as transposing each matrix first and then taking their products. Sorry. Here there's a small issue. Here there's a small issue, sorry. This is BA. AB transpose is B transpose into A transpose. Okay? So when you come to this class, my request would be the 0.2 exercise, whatever it is, it's like 3.2. Put your hands dirty on 3. Get your hands dirty on 3.2. Then only we will understand further from here. Now from here we will be slowly going with skew matrix, then skew symmetric, and then inverse calculation, inverting a matrix, and then the chapter will end. But itna karke aiye. Righto. Because more